Physics is the study of the universe and everything in it, from the smallest atoms to the largest galaxies. Physics seeks to explain how things move, interact, and change over time. At its heart, physics is about understanding the fundamental laws that govern the cosmos. Mechanics focuses on the motion of objects and the forces that cause that motion. Imagine you're walking your dog in the park. You wander along a winding path, eventually returning to your starting point. The total distance you covered might be quite long, but your displacement would be zero. How can this be? The answer lies in the difference between distance and displacement. Distance is a scalar quantity, meaning it only considers the magnitude or amount of movement. In our dog walk example, distance is the total length of the path you traveled, regardless of direction. Displacement, on the other hand, is a vector quantity. This means it takes into account both the magnitude and direction of movement. To calculate displacement, we consider the starting and ending positions. If you end up back where you started, your displacement is zero, even if you covered a significant distance during your journey. Displacement is essentially the shortest straight-line path between 2 points, considering both the length and direction of that path. Now let's consider how fast and in what direction an object is moving. Speed and velocity are two terms that often get used interchangeably, but they have distinct meanings in physics. Speed, like distance, is a scalar quantity. It tells us how fast an object is moving without specifying the direction. Velocity, however, is a vector quantity, combining speed with direction. For instance, a car traveling at 60 miles per hour to the east has a different velocity than a car traveling at 60 miles per hour to the west. While their speeds are identical, their velocities differ due to the opposite directions. But what happens when an object's velocity changes? That's where acceleration comes in. Acceleration is the rate at which an object's velocity changes over time. This change can be in speed, direction, or both. Picture a car stopped at a traffic light. When the light turns green, the car accelerates, increasing its speed. Even if the car maintains a constant speed, like when driving on a circular track, it's still accelerating because its direction is constantly changing. One of the most familiar forces we experience is gravity. Gravity is the force of attraction between any two objects with mass. The more massive an object, the stronger its gravitational pull. On Earth, we experience the constant pull of gravity, which is why objects fall to the ground when dropped. Gravity plays a crucial role in projectile motion, the curved path an object follows when thrown or launched. Think of a baseball hit into the air. The ball's path is influenced by both its initial velocity and the constant downward pull of gravity, resulting in a parabolic trajectory. To understand motion and forces more comprehensively, we turn to Newton's laws of motion, formulated by Sir Isaac Newton. The first law, the law of inertia, states that an object at rest will stay at rest, and an object in motion will continue in motion at a constant velocity unless acted upon by a net force. This means that objects resist changes in their state of motion. Newton's second law explains the relationship between force, mass, and acceleration. It states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. In simpler terms, the harder you push an object, the faster it accelerates, and the heavier the object, the slower it accelerates under the same force. Finally, Newton's third law, the law of action-reaction, states that for every action, there is an equal and opposite reaction. When you jump on a trampoline, you exert a downward force on the trampoline. In turn, the trampoline exerts an equal and opposite force upward, propelling you into the air. These fundamental concepts of physics provide a framework for understanding the world around us. From the motion of planets to the behavior of everyday objects, physics helps us unravel the mysteries of the universe and appreciate the intricate workings of our cosmos.